If you still remember, I discussed these points in part 1, followed by talking about the causes, the optical cause in the second part, and the retinal cause in the third part. And in this part, I'm going to talk about the remaining causes of aniseikonia. So let's start by the physiological aniseikonia. So in normal binocular vision, there is something called sensory fusion, which is the process by which the visual cortex combines images from the two eyes into a single image, or we can say a single percept. So imagine now we have an image for one object in the fovea in the right eye and another image on the fovea of the left eye. So the job of the visual cortex is to combine these two images into a single image. And this is called sensory fusion. But remember, the two eyes are not located in the same position in the skull. So there are some sort of horizontal separation. So that's why the images from the two eyes slightly differ, because each eye views objects from a slightly different perspective. And this produces a change in the size and even shape of the perceived image. And this depends on the position and distance of the object from the eyes. And these disparities are actually very important because in other ways, this is a kind of aniseikonia, but this is called physiological aniseikonia. And again, it is processed by the visual cortex to produce what's so-called 3-depth or stereopsis. So it's not only we are seeing the object single, but also in 3D. So we have something called stereoscopic vision. Interestingly, everyone experiences such aniseikonia if we are doing what's called asymmetrical convergence. So what's the meaning of asymmetrical convergence? Imagine now you are converging on a near object, but this object is not exactly in front of you, but to one side. So let's say this near object is more on the right side. So it's closer to the right eye than to the left eye. So as you know, since this object is closer to the right eye, the size of the image on the right fovea somehow is slightly bigger than the size of this image on the left fovea. And this could be up to 5 to 10%, sometimes it's even 15%. Again, this compensated in the visual cortex and to give the stereopsis and gives rise to no symptoms. So this is what we call symmetric convergence. So as you can see here, if we are focusing on the near object, which is located exactly in front, in the middle of the two eyes, this is called symmetrical convergence. So both eyes are adducting to the same degree and converging on this near target. So the visual axes are converging and intersect at this near target. How about asymmetric convergence? So now this cone of ice cream is located more on the right side. So it is closer to the right eye. So to experience this aniseikonia, this is a kind of experiment. So you cover your left eye and focus on this object. So imagine now you are holding a pen on the right side, close your left eye and observe this pen. It would be bigger in front of you. Now switch the cover and occlude your right eye. Same target, it will look like smaller. So you can experience this kind of aniseikonia. But both eyes opens, you can see the near target in depth. So let's summarize physiological aniseikonia. There is some sort of physiological aniseikonia, and by the visual cortex, it's important to produce stereopsis. Now going to this confusing title. What is the relationship between aniseikonia and stereopsis? We just mentioned that some sort of aniseikonia is really important, and we call it physiological aniseikonia, and this is important for stereopsis, and this is a good relationship. But If you remember from when we are talking about the, let's say, the optical aniseikonia, when there is a significant amount of aniseikonia, suppose we have a case of marked refractive anisometropia that produces significant aniseikonia, we can expect when we are testing the stereopsis in such cases that the stereopsis will be low. So sometimes we have negative relationship between aniseikonia and stereopsis. Now, moving on to the neurological aniseikonia. Sometimes it's called cortical aniseikonia. So again, it's related to the visual cortex. So in summary, sometimes we have a patient who have a cause for aniseikonia, but the patient doesn't complain. So what happens? So the cortical neural processing function to reduce the image size disparities arising from other causes, such as optical aniseikonia. And this is a kind of an active adaptive mechanism to allow people to tolerate small amount of aniseikonia without detrimental effects on their binocular vision. So it's a good adaptive mechanism, again, done by the visual cortex. So I wrote here, confusion is the first step toward clarity, because please don't confuse between physiological aniseikonia, which is done by the visual cortex to produce stereopsis, and by the neurological aniseikonia, which is adaptive mechanism to allow people to tolerate small amount of aniseikonia. And that's why some people has a small amount of aniseikonia and you have like troublesome symptoms, while others have like a significant cause for aniseikonia, but they don't complain. Because there are too many factors are in play in the processing of aniseikonia. Now we've completed all causes of aniseikonia. Before I end my presentation, so on a lighter note, let's have some interesting linguistic point. So we have two slightly similar words or confusing, which is disparate versus desperate. So desperate, we use this word in this presentation and the previous presentation when we have like disparate images on the fovea on each eye. Simply it means different. And desperate, the second one here, means simply disappointed, as this emoji. So the two words are totally different in the spelling and the meaning, and there is slight difference also in the pronunciation. So please don't confuse between both words. So I put the two words in one sentence. So sometimes I feel desperate when I misspelled the word disparate. Thanks for watching, and I'll see you in the next video, which will be about how to diagnose aniseikonia, how to assess a case with aniseikonia. And until then, take care. Bye-bye.